Okay, let's say you have a pulley at the end of a plane, and then you have two blocks of weight. One is around 3 kg, and then it's been connected by a cable, okay, or thread or string. And then there's another weight or mass of 2 kg hanging on the other side. So we can split this motion that's happening at A, sorry, the force that's acting at A separately, and then B separately, and then we try to resolve this to solve this problem. Okay, whenever you have a question like this, let's resolve the forces. Okay, and we use Newton's second law of motion, which is F equals to ma. Why? Because let's say if there's a motion, okay, movement, okay, this is A equals to ms square. Okay, so F equals to ma. So when there is a force, or I mean, when there's a movement, not force, when there's a movement, so of course, there will be forces acting. And then what are the forces? We have to resolve that first. Okay, to resolve this, we can separate them into horizontal and vertical force. Okay, horizontal and vertical. So at A, what's happening horizontally at A? Okay, horizontal mean along the x-axis. When motion, when it is in motion, the block, which is 3 kg at A, when it's in motion, so you have F equals to ma. Okay, F equals to ma, the force equals to mass by acceleration, applies Newton's second law, applies at A. So over here, force is the force that's acting on the cable, which is the tension. So T equals to m. At this stage at A, you have 3 kg, and then I don't know what is A, so I'm going to leave it as A. Okay, that's what's happening horizontally. Whereas what's happening vertically at A? Vertically you have weight that's acting downward, and then you have normal force that's acting upward, okay, to balance that. So at A, vertically, okay, vertically what's happening is R will be equal to W, which is mg. In this case, m is 3 kg, so 3 times by 10, which is 30 Newton. Okay, so now at B, what's happening at B? Okay, at B, you have the weight that's acting downward, which is W equals to mg. In this case, m is 2, and then gravity is 10, so 20 Newton. Okay, 2 times by mg, which is 2 kg, times by g, which is 10. Okay, so that's 20. So at B, you have, so if weight is acting downward, there's another force that's acting upward, okay, opposite to that, and this is the tension of the cable. Okay, so T, and since the motion is this way, so what's going to happen, this block at B, which is 2 kg, is going to pull the entire system down, so it will go down together. When the entire block goes down, so the weight minus the tension, that will give you the ma, which is the motion. Okay, so this is using this Newton's second law. The weight will be the net force. Basically, the net force, where are you getting the net force? The net force is the weight that's going down, 20 Newton, and then this is minus the tension, which I don't know. That will give me the acceleration times by mass, which is the net force. Okay, so m over here, which is 2 kg, and I don't know what is a. Okay, so you have 1, then you have 2. So let's solve these two. So 20 minus t equals to 2a. So t equals to 3a. So 20 minus 3a equals to 2a. So A equals to 20, you take minus 3 over there, which is 5A, so divide by 5 will give me 4 meter per second square. So that's your acceleration for this system when it's in motion. So T equals to 3A, so 3 times by 4, so T is basically 12 Newton.